These are the legs of a tiny army of robots. So small, they are dwarfed by a single-celled paramecium. 50 years of development in microelectronics have given us a fantastic array of tiny computer systems. But that is only half the puzzle. A robot also needs to move. And now, researchers have created a brand new type of actuator which can do it, giving the tiny brains some brawn. Up until now, making moving parts at the micron scale has proven tricky. Conventional designs often don't function very well when they're that small, while others work but rely on mechanisms like magnetism which can't be easily integrated into existing electronic systems. But the new design, called a surface electrochemical actuator, can be fabricated using similar processes to those used to produce microchips. That means the tiny legs can be added directly to the devices that control them. To make the legs, a 7 nanometer thick sheet of platinum is coated on one side with an inactive material like graphene. The legs are then patterned using a technique called lithography, and the excess material is removed. In order to work, the legs need to be in water, but the concept is relatively simple. When a current is passed through the platinum, charged water particles are attracted to the uncoated surface. The force of these particles binding to the metal creates stress on one side of the sheet, and that is what makes it bend. By reinforcing sections of the sheet, the bending can be controlled more specifically, and voila, a tiny robot leg. The robots are equipped with 2 minuscule solar cells. By shining a laser on each one, researchers can create the voltage which activates the front or back legs. These new actuators allow the tiny circuit to move, and because they are created using the same well-understood manufacturing processes as semiconductor electronics, their production can be easily scaled, making millions of tiny robots at the same time. Swarms of robots so small that they can be injected through a hypodermic syringe, and collected using a pipette. Now, at the moment they can't do much, but their compatibility with existing microelectronics makes them versatile. In theory, new actuators based on these designs could be combined with more complex devices to carry out a whole range of more sophisticated tasks. The researchers have pointed to everything from fighting cancer to tackling crop pests. But that is decades away. Time will tell if these first small steps for micro-robots could be a giant leap for micro-robotics.